Hello, welcome back. This is Gennaro, CEO of Cortex Solutions, and today we're going to be talking about secure development for IoT devices, brought to you by ACSMI. Let's get started. So IoT, we talked about it before. So this is all the other devices that are out there, right? These are devices that are interconnected within the network. Today, IoT devices could literally be your Apple Watch, health monitors, your smartphones, home systems, such as your thermostat or your refrigerator that we talked about. So there's a growing need for the security aspect around this. Why? Because they're connected to the network. Now they are a node. Now they are an access point. Now they are an attack vector. So core principles of securing IoT development. We want to start by security by design. I talked about before that a lot of times that's not the case. But more and more organizations are pushing out more and more IoT devices with this in mind, that security by design, where it's implemented in it at the early stages of development within the software. It pretty much enables us to minimize that attack surface. We want to reduce unnecessary functions, the interfaces that are open. Open ports, we want to close them if they're not needed, because these are just low-hanging fruit for attackers. Having that strong authentication. So even if we are using IoT devices, using those mechanisms, the authentication piece that we talked about before, that two-factor authentication, by ensuring that the IoT devices and us reducing the need or the unauthorized access. So encryption everywhere just basically states, hey, we're going to apply encryption at rest and transit because, well, we want to protect the data. That's the gold mine. We want to protect the user privacy and the data. Now, lifecycle of security. There's a lifecycle for keys, right? Lifecycle for the certificates, and just another lifecycle in general for IoT devices. So we know that security in mind, right? Thinking with that in mind, that we need to understand that we want to design these devices with security measures in place too. So if we're looking at from a manufacturing to always to at least the other aspect of it, of understanding that, hey, at some point in time, there's an end of life. So when we go into the decommissioning phases, this is the life cycle. How are we going to securely wipe our data from our smart home hubs, from our smart refrigerators, and all the other smart toasters? So it's all about rebuilding and looking at it from the aspect of security in mind, security first. So building these hardened IoT solutions with secure booting process, where this is where you're only going to be able to allow trusted firmware to be uploaded and loaded and reloaded, I should say. Right? If you're looking to upgrade your firmware. Now, tamper-resistant hardware, so using sensors, because this is ideal, this is key here, because that sensor can trigger a shutdown of the device itself. Now you have your secure communication channels, that TLS that we talked about, because again, this is Internet of Things, devices that are already connected. So if they need to connect to the server or across networks to gather data, to upload data, we want to make sure it's done securely. And then we talked about the hardware security module. So this is a way to hold and house these encryption keys too. Some secure coding best practices are going to be input validation. Think of the use of SQL. Right? SQL injection. You need input validation to sanitize and validate the input that's being input into the system. Because again, zero trust mindset. We're not trusting anything. Okay? We always want to verify. So you want to also have memory safety too. So you want to avoid using unsafe memory functions like SR copy. Right? Think of like being able to copy strings in a sense. Okay? Now, error handling is a little bit different. This reminds me of Linux. Because you always will know if you put in a command wrong, it's going to let you know that. But if you put it in right, you're not going to hear anything. So handling these errors are important. Because we need to know that an example of this is, hey, we're returning an access denied based upon invalid username and credentials and passwords, right? This prevents attackers from actually confirming that valid user credentials actually are there. So we don't want to necessarily leak information unintentionally. Does that kind of make sense? Right? So we want to say access denied versus invalid username, because if the attacker understands, oh, admin is a real username, I can now go in and try to do brute forcing. I can do all these other things against the admin username, or at least the profile. So restrict permissions too. So using that principle of least privilege like we talked about earlier, right? This is solely meant for if you're trying to execute code in the environment. You want to prevent unauthorized access to this, unauthorized access to the actual system itself. These are just ways you can go about protecting IoT and the communication and the data around that, using secure APIs like we talked about before. Now, using authentication keys and encryption for the actual API communication that those data calls, because IoT devices really rely on that. They are relying on calling these systems and servers back and forth. And then understanding that if you're looking to aggregate your data, because sometimes IoT data streams, they can actually reveal the trends and the systems and personal information. So you want to encrypt all that data all at once while it's in transit. So falling back on our regulatory compliance with our ISO standards, OWASP now has the Internet of Things project, similar to the web application, right? But this is more so for the IoT devices, where it's giving us guidelines. So absolutely go check that out as a resource. And then GDPR, because GDPR touches on a lot of things, and it's always about privacy. So protecting privacy and then ensuring that, hey, we're using the right standards around this. An actual real-world application. Let's talk about using encrypted communication channels, using that TLS. So the objective here is to safeguard data transmissions between the IoT device and the server that's on the network or somewhere else. So we want to implement TLS 1.3 or higher, because we're always evolving, getting more and more up to date on everything. And then we want to monitor the certificate expiration. We talked about that revocation list as well too. Now, testing the endpoint. So you want to use tools such as SSL Labs, right, to ensure that encryption quality is good, that we still have the correct actual implementation done well. Now the outcome of this is going to be the data remains safe, right? The data remains confidential during the transmission, because again, we don't want someone in the middle saying, okay, I can see this data now, I can tamper with it, I can pull it somewhere else, I can do all these things. But the example really is all about, ensuring that TLS, that encryption, is connected to something good, right? It is connected to the actual server that's supposed to be. An example of this is going to be, let's say you have your medical thermometer, all right? And we know that we need TLS or some form of encryption. Well, this ensures that that patient data, that sensitive information, isn't intercepted during the transmission, right, to the monitoring system, because it has to go somewhere to log. But again, it's been great. This is Gennaro, CEO of Tech Solutions, which is pretty much just talked about securing IoT devices and its development. Brought to you by ACSMI. Take care. Look forward to seeing you in the next one.